Okay. So, hello everyone. I'm Yann Armand, and I'm working in the London office for Yammer in the Ruby on Rails team. And today, I would like to talk to you about how we are dealing with scale at Yammer. For whom doesn't know, Yammer is an enterprise social network, and it's basically a tool for collaboration and communication within organizations. So, back in 2008, Yammer was a classical Rails application. Basically, was gathering data from Postgre and delivering for a reasonable number of users. Then, everything grown, the number of users, the number of features, and of course, the amount of data. So, how big is it now? Well, we have hundreds of models and controllers, about thousands of tests. We have 6 million users, and we process half a billion requests per day. So we are pretty big now. That means we need a scalability strategy. At Yammer, when we talk about scalability, we focus on speed. We want to get responsive and to keep our clients, our users, the best experience possible. So this scalability relies on 3 points. First is sharding, caching, and dedicated service for specific purpose. So let's begin with sharding. Sharding is basically splitting data across a cluster of machines. In our case, we use it to improve speed. I won't try to explain you what is sharding in details, because there is so many people way more clever than me that already explained that. But I just want to give you some context of the choice we get at Yammer and how we are doing sharding. So the key point of our sharding schema is to avoid cross-functional transaction, cross-machine transaction. Again, this is about speed. If we are doing transaction through several machines, we lose speed. So basically, most of the time, we want to use horizontal sharding, and most of our models rely on a given company, which we identify with the domain, the network domain of the company. So we try to host on the same machine horizontal models sharing the data for the same company. But some models are not specific to company, so we are doing vertical sharding in that case. Again, to avoid non-cross-machine transaction, we never cut a table, and one table is always stored on one machine. There is another case in active record. We have validation before and after methods, and this is always running into the transaction. So for some model, sharing different models have complex relationship and having validation between them or before and after callbacks, we host them on the same machine because they are processing on the same transaction. So, for example, on the left, we have models sharing information for our A/B testing model system, and on the right, some stuff about internationalization. So basically, we do it, share them on the same machine. So basically, sharding is about easy to grow for us until we stay on the horizontal stuff. So basically, for our horizontal schema, we can grow virtually indefinitely. This is not the case for the vertical ones. That's it for sharding. Then, for a specific problem or a given features, our Rails application use specialized services. For example, we have RT, which is in charge to deliver real-time update to the browser, or Completi, who is doing fast search to provide auto-completion in the browsers. And over the last month, we created a pretty big number of these little services to handle big problems. So how big is, for example, one of these problems is our picture scaling and delivery service can process actually 160 images per second. So we use a dedicated service for that. These services are basically HTTP RESTful service. They are written in Java using the drop wizard framework that you can get on GitHub. We are open sourcing it. And as Ryan Kennedy said, Ryan Kennedy is our head of core service system. The simpler the service is, the easier to build, easier to test, easier to monitor, and easier to repair. So let's have a look at one of them and how it is interacting with our Rails application. So let's talk about Prunky. Prunky is a relevancy service. Basically, it's core models from the perspective of other models. So what does it mean? So in the example we have here, for example, on the right, it allows me to get a list of the most relevant users that are online now for me, and I probably want to talk with them. In the right, you have a list of the groups where I am the most active, and it proposed me to, and I have them always on my sidebar. So this is basically the groups what are the most relevant to me. So this is a user-to-group relationship, and on the left you have a user-to-user relationship. So for the user-to-group relationship, basically what does the Rails application, it feeds Prunky every time a user is reading, posting, or liking something on a group. And it delivers back a ranked list, an ordered list of the most relevant objects, in that case, the most relevant groups. Well, enough of explanation, let's have some code. So what we want is to create a new Prunky index to follow the user activity in groups. For that, we create this weird name group recent user activity index, which basically inherit from the decaying rank index. So the decaying rank index is simply a service adapter which handles all the communication, HTTP and JSON communication between the Rails application and the Prunky service. So we just define that for each user, which is a scope type, we want to rank the groups, which is the entry type. Then, every time someone posts a message, we just instantiate this indexer for the sender of the message, which is the user, and we improve the rank for this group. So this is the group where the message has been posted. The cool thing is Prunky is that it integrates a decay factor linked to time, and the idea is to normalize the value. That means when I just join a group and I'm starting to be active in that group, it will be instantly ranked with the other ones where I am the most active for a long time, because it basically degrades the rank with time. So this is why it's called Prunky, because it does prospective ranking. How we get some results? So in the user class, we define the method top groups, and again, we instantiate this long name index. We ask top rankings, and it just gives us, as a result, a sorted list of group IDs, and these group IDs are the IDs of our active records. So we just have to ask active records to get the object. So, Pranky is quite a very simple service, real-time service. It's doing simple calculation on simple data. If we would have to calculate this scoring between models using active record or complex SQL query, it would be much more difficult. That's just a mathematical calculation as we do with Pranky. And it will have been a very big impact on performances. And so we at Yammer believe that we have to use the right tool at the right place. So we are doing more and more of these little services. That's it for services. So let's talk about the third part of our scalability strategy, which is caching. So when you start a RAISE application and when it grows, basically very rapidly, you will need caching every time. And then you have a lot of different options you can choose. So let's go through. First, you can use page caching. Basically, page caching is working well for static stuff. So it basically doesn't work for dynamic data, and we believe in Rails application, most of our stuff are dynamic. It doesn't work either for authentication stuff. So let's forget about page caching. We can also do action caching. So that handles different data. But you have the problem of the perspective of the data. Depending if I am an administrator or a user on my website, I don't want to have the same behavior. So I don't really can use the action caching. Then we have a pretty cool stuff in Rails, which is fragment caching, that basically we can cache part of the code where we want, but it adds some complexity. And when your application grows, you have already big complexity through models and controllers. So we don't want to really add another complexity layer on that. So we decided to use record cache, which is a gem. And basically record cache is simply, it caches the database queries. So how does it work? Well, we define an active record, and for that active record, we say we want to cache by ID or by email. So the first one, what does the first line? It creates a cache entry for that record, so it caches the object. And on the bottom, you have the key of the entry in the cache, which is basically the name of the class. 2 and 3 are two numbers to represent the record cache version and the version of this class, in the cache, the file name and the value of the file, of the field, Then you can simply use the classical active record finder. Find by ID, what it does is search in the cache the object and return it to you. Let's do more funny stuff. Let's create an entry by email. So it creates another entry. Basically, same stuff, the class name, versions, the name of the field, the value of the field, and what it returns is an ID. So when we use find by email, he hit the cache 2 times. First time, from the emails, he gets the ID of the object, and then we hit the cache a second time, and we get the record from the ID. Yes, we hit the cache 2 times, which is slow, but it is definitely faster than asking the DB to get the record. So let's do more fun stuff. We can define indexes with scope. So in that example, we define an entry for department ID only for the user where the state is active. Because of a little problem on the gem, we have to define the name. It can't be defined automatically, so it is active user. That means we can use active user find by department ID, and we will get only active users for that department. So if we feed the cache, sometimes we have to invalidate and make some clean stuff. So for invalidate one object, we simply call invalidate record cache on that model. You don't really have to care about that because it is automatically called when you call a save on any active record. If you want to invalidate a full class, you can increment the cache version for that class, which is basically exactly the same thing that calling invalidate record cache on the class itself. Well, do we have any issue with record cache? There is some. First, rendering. Even if it's fast, even if we are getting data, we still have to render them in views. So we have to keep in mind that the lighter the view is, the faster we get, finally. Something else is, if you are doing raw SQL updates, you will have to handle the cache invalidation by yourself. The same rules apply to the migration, because migration are basically SQL updates. Then, active record chaining. Well, defining an index on two fields to use find by something and something else, it didn't really support it in the gem yet. So for one scope it's okay, for more than one scope it's not very clear, but in most of the case you don't create indexes on cache on things you want to chain. But if one of you guys or a team of you guys want to dig into that problem of chaining, just contact this guy, Matt Duncan, at Yammer, and he would love to help you. Well, how well the cache is working for us. On a non-numerical plan, it works pretty well on every case we went through. We don't really care about it. We just create more index in our classes and we feed the cache more and more. If we want to look at the numbers, we just say that we measure that we have 98% of our actual requests hit the cache. That means only 2% of the requests go to the DB, which is pretty awesome. And to give you another number, we have 20 billion memcache hits per day. This is pretty huge. So for us, caching, it works. Well, I'm pretty done with my talk. Just a little summary. We at Yammer are doing scalability through sharding, core services, and caching. And that's it. Thank you very much. If you have any question. Yes?
How are you handling the memcache?
This is memcache, yes.
Yeah, so you're using a memcache, and how do you scale this memcache? You probably need to share it all over your machines, right? Or the cache work.
Yes, I'm not a super efficient. I'm not in the team handling that. We have infrastructure team taking care of this. But I guess because of the horizontal and vertical sharding, I guess we also do the same on memcache. So we are on the same machine, the data, because record cache is caching the SQL stuff. So we probably host the memcache on the same machine where the data are. So you just follow the sharding schema. We selected one, yeah, one by one. We create indexes, and for one active record, we can have several different indexes, depending on the finder we want to use on these records. Yeah.
You mentioned that part of the services are written in Java. Why Java? Why not Ruby?
Why Java? Why not Ruby? Just because efficiency, we have. It is efficient. It works pretty well. It's fast. The JVM works pretty well, and we have guys. And it's a question of team also. We easily find guys that are efficient to do this kind of stuff. But I'm not the guy making the decision on this. But it works. That's really cool. There was another question here? Yeah.
Are you developing the final cache in Yammer, and is that going to be a Rails 3 compatible version?
Sorry?
Rails 3 compatible version, where you have this where clauses instead of find by stuff.
In Rails 3, I'm not sure I understand the question. We are using Rails 3. Yammer is a Rails 3 application on top of 1.8 Ruby, Enterprise Ruby. Does it give you?
I mean the new active record query interface is not find by.
Oh, so I don't think so. No. We're stuck on find by. We are using a lot of find by.
The services, they're accessible via JSON?
Yes, HTTP and basically HTTP and they deliver us JSON as results.
Do you apply any caching on that?
I didn't mention it, but the database behind the active records is React. So we directly get the speed from React database itself. Yes?
Have you got any numbers on how caching improves the performance?
Not really. Just the fact that we have users all around the world and it is responsive for everybody. And it's just a general feeling on it begin to be slow, and then we are basically when we have we do analytics on our performance, and when it's becoming to come slow, we get at the code and we add some indexes and we cache more. And that's it. But I don't have numbers, sorry, on that. Okay.
So I hope you all enjoyed Yann's talk. There has been a little change in the schedule. Laura this afternoon will switch with Ryan tomorrow, so that's the only change. It's not in the book, of course, but you can see it on the website. So have fun and get out for a coffee break.
Thanks.
Oh, maybe you can see. You get a
Whoa, nice.
glass, which is a Belgian beer. Yeah, you know it's pirates.
Cool.
So I hope you enjoy it.
Thank you very much.
If you want to keep it until the end of the day, or
Yes, would be
we,
great. Cool.
you know, get in touch with it and we'll
Yeah,
pass
cool.
it on to you. And you may keep the head too.
Yeah, thank you very much. That's cool. Hey, nice to meet you. Nice to meet you. Yeah. Yeah, Sibyl. Hey, what are the schedules that I want to attend?